This meeting is being recorded.
Okay, welcome. My name is Amozo Cosmas, and my group mate Wairagara Eric Peter. We are going to be presenting the our research topic is leveraging machine translation for medical translations for Ugandan languages. As you know, Uganda as a country, or generally, is a multilingual country with over 20 known languages, and all these language speakers in all these 20 languages happen to access medical health care. And Uganda has embraced English as its official language, and we can say the biggest section of the land community is well versed with the language, but the ordinary person at the lower level, I would say, like maybe people who approach like healthy center 1s, 2s, and 3s are not at the village and sub-county level are not that learned. They are not well versed with English. So our study case is on Luganda, English to Luganda. Our study case is on Luganda specifically, and how machine translation can improve medical processes in Uganda. So I'll begin with our introduction. With the advancements in machine translation, there are still a few industries where it hasn't caught on as much as it has elsewhere, especially for African low-resource languages like Luganda. There are few English to Luganda translation models out there, and there is need for these languages to be translated as so many of their speakers access services, especially in the medical field. This is no surprise that with the sensitive nature of its content, that the high quality requirements of the medical translation, life sciences is one of them. The medical field is one of those critical fields since it involves life, and we believe that translations must be made in this field to help the ordinary person access healthcare. So the advent of neuro-machine translation has made that cautious approach obsolete. Many cases in the medical industry where the use of machine translation can add enormous value for the African community. Translating from English to any local language would be a huge step, and it will make doctors who don't know some of this language. It's hard for a doctor to know all the 20 languages spoken in Uganda. He will know two, but he will be deposited somewhere. Maybe naturally, if he's a Muganda and he has to interact with the locals, or if he's a Choli and is deposited in Uganda, in the Buganda region, he has to know at least some Luganda, be able to interact with the patients. So we explain something little about machine translation, automatic translation from one natural language to another, where you have a source text, and the text, like maybe how are you doing, it can be broken down into phrases, like phrase one, phrase how are you, then like those phrases must be matched to the equivalent in the other target language, in this case, which is Uganda. Yeah, so that's the entire architecture of machine translation, having phrases broken down and then mappings being made to the target language. Our problem statements is to build medical translation MT models for African languages. Like I said, our target is for Uganda. In this case study, we hope to build an inclusive medical machine translation prior corpus to the development, to the model development. Our focus is to build machine translation models specifically for Uganda in this case, that will be inclusive, which means we expect to eliminate gender, racial, and dialect biases in our model. And like we acknowledged earlier, medical personnel have had difficulty explaining medical jargon to ordinary people. You know, the medical jargon is one of the things, if you've never done medicine, however much you're educated, it's very hard to understand. So machine translation presents an opportunity to overcome these linguistic barriers, hence improving clinical consultations and reviews. So once these linguistic barriers of the patients not understanding the jargon and the doctors not having a way to express themselves in a way that the patients will understand, these barriers can only be broken down by machine translation. Related works, we acknowledge works from other researchers, and one of them is the machine translation for African languages, the community creation of datasets and AI models in Uganda by Akera. Research that involved building datasets for African languages, and researchers adapted several multilingual pre-trained baseline models. This is by Adlelani. It's also 2022. Gender bias evaluation for Luganda to English machine translation. This was done by one of the authors for this particular research, and that's Eric Wairagala. And then machine translation of medical texts in the CRESMON project by DUSEC, and then development of machine translation technology for assisting health communication, a systematic review by Dewitt. So all these will be included in the review section for further reading. And then the research gap, the current state-of-the-art machine translation works seemingly well for other tasks. However, these translation models have trouble translating high-level medical jargon into simple, understandable phrases in local languages. These models exist, or these research works exist, but there's still a problem of translating this high-level medical jargon into simple phrases for the common man to understand. Yeah? Hence, unable to bridge the gap between clinicians and patients in countries like Uganda with high levels of illiteracy. Like I told you, like at the sub-county levels in rural areas in Uganda, health centers at health officials at health center ones, twos, and threes struggle a lot to explain medical jargon to these ordinary people. And there is a gap there that needs to be bridged by machine translation. The research questions we've asked ourselves is, how complicated is it to create a medical machine translation parallel corpora? And we shall answer these as we shall answer some of these research questions in our proceeding works. To what extent do medical terms and abbreviations affect performance of machine translation models? How can we evaluate practical applications of medical machine translation models? Yeah, how can we evaluate the practical applications like clinical trials, prescriptions, clinical consultations and reviews, post-drug market surveillance, all these, how we can evaluate them with medical machine translation models? What measures can be used to evaluate medical machine translation models against ethical fairness and transparency issues? Yeah, how can we evaluate how these models perform when it comes to gender bias, racial bias, and dialect bias? All these are things we look to answer in the due course of our research. Let me welcome my group mate, Eric, to proceed from there.
Thank you so much, Cosmas. So as he has mentioned, machine translation in the medical domain is a little complex, and limited work has been done to actually combat the issues of medical terminologies and that are not understandable by the people around in the local context. So we are working with machine translation for Uganda in the medical context. So our methodology starts with the data collection and selection of these sentences that contain medical terms that we shall be using in this whole process. We look at the data pre-processing pipeline and curation, where we shall be creating these sentences from the sources that will be mentioned in the preceding works, and also translating translating the sentences to create a parallel corpus that will be used to build models, also train the models. So the models, the data set will have the test set, the training set, and also the evaluation set to help in the model performance evaluation. Then next slide, Cosmas. Then we have some limitations for this particular work. For example, limitations from the dataset point of view. There is a lack of existing dataset for Ugandan languages for the medical machine translation models, and also there are some existing biases in the datasets that are available. For example, like the work that has been referenced, there is an anchoring bias that is actually existing in the information that was used to train these models, and also limitations to do with social biases. For example, social status, social bias in the social status, whereby doctors and clinicians tend to communicate differently to several people, several types of patients in the hospitals. For example, with a patient of a high status, that doctors tend to go direct, or maybe they sometimes simplify more the information more to their understanding, which is not the case with patients that don't have insurance or something. Then lack of domain experts to actually help out in the creation of the data sets for the specialized audiences, as customers has mentioned, for people in local communities that are actually using this information in a more informal way, whereby prescriptions are being written in English and sometimes they confuse the patients. And then also abbreviations and words that are used in the medical documents would be, they make it hard for people in the local areas and people who are who are not literate enough to understand what is going on. Then there is an issue of computational power to actually build and train these models. So as we shall see in the next slide, shall be proposing some solutions to actually combat these issues. Next slide. So our proposed solutions is to work around with a limited number of experts like clinicians, linguistics, and patients to create a more diverse and inclusive data set with limited bias. And then we hope to use Google Colab and Hugging Face for training these machine learning models and deployment. We are going to leverage the existing data sets for English to Uganda text translations to create new data sets for this particular case study, and then build a test set to evaluate our model, focusing on the translation quality and ethical issues that are being mentioned above. Next slide. Then, yeah, so some of the supervised and unsupervised learning techniques that we came across are neural machine translation, which specifically works with the neural networks with the state-of-art performance. So this, and then we have statistical machine translation. Then we have unsupervised neural machine translation, which actually doesn't require labels to train the machine translation models. And the same thing is applied to the statistical machine translation, unsupervised statistical machine translation model, where we don't provide data to train the language model, and also to test, we only provide data to test these models for performance. Next slide. Yeah, so some of the metrics that we are required to pick from for this particular case study are precision, recall, accuracy, F1 score, and sensitivity. And for precision, it's the ratio of the correctly predicted positive observations to the total positive observations. And then recall is the ratio of correctly predicted positive observations to all observations in the actual class. Then for accuracy, being the ratio of correctly predicted observations to the total observations in the whole case study, and also F1 score being the weighted average of precision and recall. So we have sensitivity here, which is also termed as recall, which measures the proportion of actual positive cases that got predicted as positive. Then in this case study, we hope to leverage precision, recall, and F1 score, since they are standard measures that can have significant correlation with the human judgments than the recently proposed alternatives, like the blue score, which is the bilingual encoding understudy matrix. Then next slide. So we motivated by the linguistic barriers in healthcare, especially in multilingual countries like Uganda with low literacy index, we propose a machine translation model to improve communication between clinical personnel and patients. So we hope to expand this work to other domains like agriculture, education, and so on and so forth.
So,
yes, so Cosmas, do we stop recording? I don't know.
let me stop recording.